Let's take a look at urine formation. Now remember again, there have to be three processes which must occur if you want urine formation to occur properly inside the kidneys. The first one is filtration. Now remember, inside the kidneys that there are these capillary networks called glomeruli. They got tiny little holes in them called fenestra. So that's going to make those capillaries more porous than what most capillaries are in the human body. As blood is moved into these capillaries, some of the plasma is forced out through those holes. Now those holes are extremely tiny. They're going to hold back anything large back in the blood in that plasma, because anything large is valuable and you don't want to be losing it. So all the cells and even most all the proteins get held back by these holes. So that means they're very tiny. But of course, water, waste, and excess materials is primarily what gets through. That's far more than 99% of urine right there. Then there's trace amounts of other things like hormones and so on. So first, you must filter some of the plasma out of the blood and put it into the nephron. That's filtration. That's step one right there. After you put this plasma into the nephron, you call it filtrate. Now the cells, which are just epithelial cells of these nephrons, are going to reabsorb over 99% of that filtrate. Reason being, almost all the plasma and almost all the filtrate is good, useful material. A tiny amount, less than 1%, is all that you ever want to be losing. So when you've moved some of that plasma out of the cardiovascular system and put it into these nephrons, you're going to reabsorb just about every bit of it. Now remember, the Bowman's capsule, which is the first part of the nephron, is what's around the glomerulus. So it just catches all that plasma when it leaves those tiny holes in the glomeruli. That's all it does, catches that plasma, then you call it filtrate. No reabsorption there. But then with the proximal part of the tube, you get another 65%. Loop of Henle 15%, and the distal tubule and collecting ducts around 19%. And that last percent can vary a bit depending on how little or how much of certain hormones are released, like ADH, aldosterone, or ANH. So that's where those hormones work, are on the last parts of the nephron right there. So almost everything gets reabsorbed. A lot of people think what the kidneys are doing all day is pumping bad stuff out of you. No, where almost all their energy goes is to pulling good stuff back into you. And when those epithelial cells of the nephron reabsorb this stuff that you want to keep, it'll be pulled into the interstitial spaces of the body, and a second capillary called the peritubular picks it right back up. So look what you did. You let some of the plasma come out of the blood. What you did let move out, you put almost every bit of it right back into the blood. Now the cells can secrete some things inside the nephron. That's the secretion part. Be some things like hydrogen and potassium, but not all that much. But look at the solute concentrations that we'll have to look at. Now think about water. Now this is going to move easily through those tiny little holes in those glomeruli and into the nephrons. Again, that's what the filtrate is. And of course, there's no pure water anywhere in the body. There's always materials dissolved in it. Lots of little solutes there. So more than 99% of this filtrate is going to be pulled back into the body. If you look at the huge quantity of water that goes into these nephrons every day, you've got to be pulling most all of it back. You'd lose way too much water too fast. So the average adult's going to make around 1.4 liters of urine a day. Of course, that'll vary quite a bit depending on how much the individuals have to drink, how much they were losing water through sweating, and so on down the line. Look at proteins. Almost every bit of that is held back in the blood. Very little of that ever gets through those fenestra holes in that glomeruli. So most of that's held back in the blood. What little does get into the nephron ordinarily is rapidly reabsorbed. That way you're not losing any of that valuable material. Then glucose. Now glucose is small enough it can get through those holes and get into the nephrons, but that is rapidly reabsorbed also. You should not be seeing sugar in the urine. The kidneys never, without exception, get rid of sugar on purpose. They don't do it. Sugar is only lost after all the sugar transporters have been saturated. In other words, there's just more sugar in the nephron tubes than what the proteins can transport into the body. So it never loses sugar on purpose. Now, you'll sometimes see sugar in the urine of people like diabetics with diabetes mellitus, but the only reason that sugar is there is because so much goes into the nephrons because the people have blood sugar levels which are way too high. So much goes into the nephrons, there aren't enough transporters for it. So it's lost completely unintentionally. And then as that solute sugar is lost, water follows it. And that's why they have a high urine output. It's what's called osmotic diuresis, because the law of osmosis is acting as a diuretic on them right there. So don't let anybody tell you the kidneys ever get rid of glucose on purpose. That does not happen. So if you look at urea, that is what's going to escape out of the nephrons right there. A little bit of water, that way it'll flow, waste and excess materials right there. And again, that is less than 1% of all the filtrate escapes is what we call urine. That urea is just one of the most common waste products in it, and that's where urine gets its name. But look at these different fluid flows going through the kidneys. Let's first mention the renal fraction. Now, this is how much of the cardiac output is actually going through the kidneys. Now, your kidneys receive a huge amount of blood. That can range from anywhere from about 12 to 30% of all your blood. Think about when you get that big variation in percents. Think about when you're very physically active, and that sympathetic division of the nervous system is activated. It's going to dilate blood vessels going to heart, lungs, and skeletal muscles. So that means it needs to be pulling it from somewhere else. The kidneys are a good place to pull it from. So when you're very physically active, you're going to be sending less blood to the kidneys, and the percent would be very low. Think about when you're sleeping, resting, whatever. Then you don't need such a large amount of blood going to heart, lungs, and skeletal muscles. You can afford to dilate the renal arteries and send much more to your kidneys, and that's when it might be as high as 30. But on average, it's probably somewhere around 21%, give or take a few percent. So if you remember the cardiac output calculated back in the heart chapter, comes out to about 5.6 liters of blood. Well, that's how much blood your heart pumps in a minute. We just said, on average, about 21% of your blood is going to your kidneys through those renal arteries. So there's your cardiac output, 5.6 liters, multiplied by 21%. Comes out to about 1.2 liters of blood a minute. So that's a lot of blood every minute. So there's how much blood's going through your kidneys. Look at the renal plasma flow. Well, we just calculated how much blood was going through our kidneys. Plasma makes 55% of that. So 1.2 liters times 55% gives you 0.65 liters there. Now let's look at the glomerular filtration rate. That is how much of that renal plasma actually gets through those tiny holes in the glomerulus. So not all the plasma does. If you let it all escape through those holes, well, you'd have no more water in your blood and it wouldn't flow. So around 19% of the plasma does get through those tiny little holes in the glomeruli. So if we want to look at glomerular filtration rate, we look at how much plasma goes through the kidneys every minute. We just said that was 0.65 liters. And since about 19% of that plasma gets out of the cardiovascular system, through the glomeruli into the Bowman's capsule, 0.65 times 19% is 0.125 liters right there. So that comes out to around 180 liters of filtrate a day. That is a huge amount of filtrate. So that goes to show you the kidneys are reabsorbing a massive amount, almost every bit of that, right back into your body. And this glomerular filtration rate is largely how kidney function is measured. You want that to be as high as possible. But again, of that 180 liters a day, only about 1.2 or 1.4 liters are actually going to leave the body as what we call urine. So that's less than 1%. Comes out to about 0.8 of 1% or 0.008. So 0.125 we said was the glomerular filtration rate. Less than 1% of that will be lost. Comes out to about 1 milliliter a minute. But again, about 1.4 liters a day is what you'll have being made in urine. It varies quite a bit depending on the individual, how much fluid they've had to drink, how much they're sweating, things like that. So there's some of the other pictures too.